Hi friends, welcome to B.Tech. Today I want to explain key management in IP security. So in IP security, we are using two protocols, EH and another one is ESP. So when you are using these two protocols, you have to generate a key. The EH provides authentication and ESP provides encryption. After completion of authentication and encryption, the final step is producing key. So how will you produce a key? Generally, there are two types of keys here. So two pairs of keys we are using for AH and ESP. The two types of keys are manual key management and automated key management, or automatically the key will be generated. So in manual key management, the system admin has to generate or configures every system every time. But if you use automized system or automated key management, there are two keys are two algorithms. By using these two algorithms, once the connection has established, so after completion of the two are combining these two EH and ESP, directly you can add this key to these two. That is the procedure of this key management. So almost all nowadays all are using this automated key management. So the first one is Oakley. It is a determination protocol, and ISAKMP, that means Internet Security Association and Key Management Protocol. So now we will see one by one. So first we will see Oakley. So this is a automated key management, the first one. By using this Oakley, you can exchange a protocol. Here exchanging protocol is nothing but exchanging of keys. So for example, I am taking A and I am taking B. So it has two keys. So one is private key and another one is public key. Similarly, B has private key and public key. So both are exchanging. So that exchange process is implemented by using this Diffie-Hellman key exchange. By using this Diffie-Hellman key exchange procedure, you are exchanging of private key and public key of A and B. Now, what are the features to address the weaknesses? So, cookies, groups, nuns, and the Diffie-Hellman key exchange with authentication. So, all these are the weakness. When the key exchange process, sometimes the attacker may attack maybe on private key or public key. Most probably they are attacking on public key because private key is more secure. That's why they cannot touch private key. So the attacker, they can touch public key only. So can use arithmetic in prime fields or elliptic curve fields. That's why when you are taking a variables, always you are taking a positive integer, that too prime fields. That means prime numbers only you are taking. Now coming to ISAKMP. So in this Internet Security Association and Key Management Protocol, it provides a framework. So in Oakley there is no framework, directly you are implementing. But when you are using this ISAKMP, it uses a framework. What is the purpose of using this framework? So in framework, they are arranged in a sequence, one after another. So the first task is completed, then only the second task will be executed. So like that you can write the program. And coming to the procedure and packets of information, so you can modify and you can delete. That means you can alter the message. And when you are implementing this ISAKMP, they are independent of key exchange protocol. In Oakley, you have used Diffie-Hellman key exchange. So while exchanging the process, the attacker may attack on public keys, but Here they are independent, no need of using this key exchange in encryption and authentication method. Now, how the framework will be in ISAKMP? So, let us consider the total size is 32, if it is a 32 bit. Now, so initially you are introducing cookies. So, initiator cookies. After that, you are checking whether the cookies are responding or not. You have to check, because if the cookies are not responding, there may be a chance of attacking the attacker. So, the second procedure is responder cookie. So, always when he is sending or he is initiating, so he should get the acknowledgement. Now, so this is the next payload. So, next payload means the data, and MJVR means major version, MNVR means minor version, and exchange type, what type of exchange is to be done, and flags. So, the purpose of flag is how many times it is exchanging the keys, and message ID. Once you are providing all these topics or all these fields, you have to assign an ID to total message. So, based on this message ID, the receiver will know, okay, the message was sent by sender, and you have to find out the length of the message. In general, if you are using DES algorithm, the size is 64. If you are using AES, maybe it is 128. So, based on the algorithm, the text size will be increased. Now, this is the main header. Now, this is the payload header. So, that means this one. So, this is the next payload, and these are next 8 words are reserved, and this is the payload length. So, payload means the total data, that is plain text PT. So, this is a generic payload header. Now, how to exchange these payloads? So, it have a number of payload types. What are the different types of payload types? Security, yes, already we have covered, and proposal. So, what type of proposal you are implementing, and transform. So, is there a necessity of implementing transformation or inverse transformation, or key? So, it is a secret key or private key or public key. Mostly you are using public key. So, private key and public key. And identification. So, you need to identify message ID and provide security. So, certificate, who will provide? The CA, that means certificate authority will generate a certificate. So, hash. So, that is represented by hash. Hash code you are generating, and signature means digital signature. Nonce means one type of message, and notification. So, after applying all these operations, you will get the notifications before sending the data from sender to receiver. So, if there is any problem in that message, you may have an option, delete option. After that, the framework has 5 types of message exchanges. Already in Diffie-Hellman key exchange algorithm, there are some drawbacks are there. While transmitting the key exchange, there is a problems. To overcome those problems, you may have some different types of exchanges. One is base, identity protection, need to generate identity, and authentication only. So, need to provide identification. So, based on this identity protection. Now, aggressive. So, this is also dependent. So, finally, informational. So, total block size will be processed. So, this is information. So, by providing all these techniques, the key exchange will be done securely. So, in this way, the key management is applying on EH and ASP. So, this is AH, this is ESP, it provides authentication and it provides encryption. So now I am clubbing this one. So here our key management will work. After completion of AH and encryption, here you are providing our key management. So in this way you are generating a good ciphertext. Thank you.